Morning, everybody. This is Mr. Dooley, obviously. And if you want a little audio with how to solve these exponential equations with the same base, you got me. So what these are exponential equations. You are going to be solving for a missing exponent, okay? And the key is going to be that you want the numbers on the left and the right to have the same base. So you could see in this first example, these are obviously the same base. And so once they're the same base, you obviously just cross them off. You got x equals 5. Some of these are really super easy. Most of these problems, what you're going to have to do is you're going to have to rewrite with a specific type of base. So, for example, you could see that these two bases right here are 6, but the square root is not written as an exponent, but you can write it as an exponent. The square root is the 1/2 power, and so x would be equal to 1/2. So, pretty easy. And then the third example, you already have the same base, so you just cross them off and you set those two exponents equal to each other, and you get x equals 2. So those are really simple examples. So the examples that follow are really kind of more in line with what we're going to be doing in pre-calc, where you have to figure out what the base is for the common base between them. It usually will be obvious if you have any sense of numbers, which you should, since you've made it to pre-calc. You should know things like 3 squared is 9. So when you're looking at something like this, we want to kind of figure out what's the common base. Common base is 3, and so we would change 9 to 3 squared. We would change rad 3 to 3 to the 1/2. And you learned in both algebra and in algebra 1 and in algebra 2 that when you raise an exponent to an exponent, you multiply. So this is 3 to the 1/2 x equals 3 squared. You have the same base. Cross those off. Set the exponents equal to each other, and you get 4. Some of them might be a negative exponent like that. You see 27 is 3 to the 3rd. But 1 over 27 is 3 to the negative 3rd. So this is 3 to the x equals 3 to the negative 3rd. Clearly, 3's cancel out. X equals negative 3. I'll come back to number 6 in a moment because there's a little trick for that. But 7 and 8 are both similar, where what you're doing is if you multiply with the same base, you add the exponents. So what I would do is I would add the x on the left and the x plus 4 on the right. Cross off the 7's, same base. 2x plus 4 equals 8. X equals 2. Same thing here. That's going to be 8 to the 2x plus 3. We add those exponents. Now, here's something interesting. We don't have the same base here. These are not the same. But we can make them the same. You see, 8 is 2 to the 3rd. So what we do is we replace the 8 with 2 to the 3rd. Multiply, because you're raising an exponent to an exponent. Cross those bases off. Now that you have the same base, cross those bases off. 6x plus 9 equals 13. 6x equals 4. X equals 2/3. All right, now let's take a look at 6. 6 is really kind of interesting because you have 8. 8 is 2 to the third. You have 27, which is 3 to the third. So what I'm going to do is I'm going to change that to 2/3 to the third. I'm rewriting 8/27 as 2/3 raised to the third power. Now, we had that x there, so it's really times x. Now, you're probably thinking, Mr. Dooley, 2/3 is not the same as 3/2, and you are correct. But what we could do is, I could reciprocal. I could raise this to the negative first power. If I take 2/3 and I raise it to the negative first power, that would give me 3/2. And then I could do that. So what I'm going to do is, I'm going to change this to 3/2 to the negative first. So this is going to be 3/2 to the negative first raised to the 3x. This is 3/2 to the negative 3x equals 3/2. There's, by the way, there's an imaginary 1, not an imaginary number, but there's a 1 as an exponent so that when you cancel these, you set negative 3x to 1, and then you get x equals negative 1/3. So that's it. That's how you solve those problems. And there's a bunch of problems here that you will do, getting the same base as to what the bases are. You could kind of see what you see here is pretty standard from when we do these problems, like a base of 2, a base of 5, 2 and 5, 3. That's a popular number. This is kind of 11 is a little bit out of whack, but you should know that 11 squared is 121. So that's it. That's how you would do these problems. Good luck, and I'll see you on Wednesday. And a few more on the back. So there's 18 problems for you guys to work on. Most of them are going to be pretty obvious.